Let us have one question on the basis of the reactions which we have studied. Question is, what is the structure of the product form when D plus glucose reacts with hydroxylamine to yield an enzyme? Let us see the solution of this. As we know, glucose is the aldohexose, and the reaction which is given in this question is with D-glucose. That means the hydroxyl group on the penultimate carbon, it is on the right hand side. Let us draw the structure first, then we will see the product formation. While writing down the structure, open structure of the glucose, write down the 4 carbon atoms in a row. Write down the CHO group, that is aldehydic functional group, in this way. At the end of the structure, write down the CH2OH group. After this, we have to write down the 4 hydroxyl group. OH, H, OH and OH. This one is the penultimate carbon atom on which hydroxyl group is on the right hand side. Just write down the other things, that is hydrogen and OH group where needed. So it is H, it is OH, then it is H and H. So this is the D form of the glucose unit. Let us write down the reaction with the hydroxylamine. When we treat any carbonyl compound with hydroxylamine, it will give out water as the elimination product. A smaller molecule, that is water, is eliminated and we will get the enzyme formation, right? So on the arrow I am writing dehydration, that is removal of water molecule. Again you have to write down the enzyme as the product. For that purpose, follow the same way of writing the structure. The 4 carbon atoms, the CH2OH group, OH, H, OH, OH. This is a D form, right? Again, H, OH, H and H. Okay, rest of the things are same. We have to show now the enzyme formation, right? This is how we can show the enzyme formation. C double bond N O H. This is nothing but the enzyme formed by the reaction of D-glucose with hydroxylamine. Here you can see in the question they have given a plus sign. The plus sign is nothing, not at all related to the D and L nomenclature system. Plus sign indicates the dextro-rotatory optical rotation that comes in the optical isomerism, which we are going to study in detail later. So we have studied that glucose is having 6 carbon atoms and it is having carbonyl group. But carbonyl group can be anything. It can be aldehyde or ketone. So we have to find it out whether it is aldehyde or ketone. For that purpose, we can carry out reactions which are discussed further. The first evidence is the oxidation of glucose molecule by mild oxidizing agent, for example, bromine water. You can see the reaction. Whenever glucose, you can see the reaction. Whenever glucose is treated with bromine water, it gives gluconic acid. That means it is having the aldehydic functional group, because aldehydic functional group can be easily oxidized by using mild oxidizing agent to COOH, that is carboxylic group. Along with the aldehydic functional group, Glucose is also having the hydroxyl or alcoholic OH group in it. To find it out, that is how many OH groups are present in the open structure of glucose, we can perform the esterification reaction by using acetic anhydride. Whenever any alcoholic OH is treated with acetic anhydride, it gets converted into the acetate, that is ester. Glucose is converted into glucose pentaacetate, which indicates glucose, that is open structure of glucose, it is having 5 alcoholic OH groups in it. The presence of CH2OH group can also be proved by using the oxidation of the glucose by a strong oxidizing agent, for example nitric acid. Whenever we oxidize glucose by using the nitric acid, it gives saccharic acid. In saccharic acid, both the aldehyde of the glucose and CH2OH of the glucose has been completely oxidized to COOH, that is carboxylic acid group. The same product can also be obtained by the oxidation of gluconic acid, which proves that in glucose there is aldehydic functional group, that is CHO, and at the end it is having CH2OH group.